Well, welcome to this online revision session for AQA FP1, in which we will be considering the June 2011 question 7 on matrices and transformations. As you can see in the first part of this question we're given a matrix A, and in part 1 we're asked to calculate A squared, which means we've got to take this matrix and multiply it by itself. Now, while we're doing matrix multiplication, we have to remember that it's row times column. That gives you one number. So if we take the top row and multiply it by the first column of the second matrix, we get -1 times -1, which is +1. A root 3 times a minus root 3, which would be -3, so that will give us an answer of -2, and that will go in the top entry, first column. We then take the second row by that first column, that will give us -root 3 and another -root 3, so that's -2 root 3. And if we do the top row with the second column, we got +root 3 and another +root 3, which gives us +2 root 3. And then finally the second row with the second column gives us -root 3 root 3, so it's -3, and a -1 and a -1 gives us +1, so again that gives us -2. 2 marks there, one for an appropriate method and obviously an accuracy mark also associated with the answer. If you only get 2 entries, if you've got to get at least 2 entries to get the method mark, but you wouldn't get the accuracy mark then. Moving on to part 2, it then says work out A cubed. So we can see that to get A cubed we've got to take A squared, so that's the answer that we just got. And we will have to multiply it by A once again. And so if we do that, we're going to get, you can see you've got -2 times -1 in the top row with the first column, and a 2 root 3 times root 3, which is root 3 is 3 and 2 6, and then the 2 that we got, making that entry 8. Similarly the second row with that first column gives us +2 root 3 and -2 root 3, which makes 0, and the top row with the second column gives us +2 root 3 and -2 root 3 again, which is 0, and then finally we get the second row with the second column, which gives us +2 root 3, which is 6, and then -2 times -1, which is +2, so again that gives us 8. So there is our solution, 8008, and if we look at the question it says we've got to write it as a multiple of I, so we can see that this is just 8 lots of the identity matrix, and remembering that the identity matrix for 2 by 2 matrices is 1 0 0 1. That's the matrix that you multiply by and will have no effect on any other matrix that's 2 by 2. That's your identity for multiplication. So here we've got the fact that K is equal to 8, therefore. Again, there's 2 marks for this part. So again, an appropriate method where you've got at least 2 entries right, and for stating the answer as 8i. So it's an accuracy mark and a method mark for that particular part of the question. Right, Now into part B. Now part B says describe single geometric transformations or combination of two geometric transformations corresponding to each of these matrices. Firstly, it asks you to state what A cubed is. Well, A cubed, if you remember, was the matrix 8, 0, 0, 8. And we should know that that is the standard form of an enlargement. And we can see that the 8, 0 in the first column is telling us that the base vector I is being multiplied by 8. And the second column is telling us that the base vector j is being multiplied by 8. So this is an enlargement with a scale factor equal to 8. And strictly speaking, we should say that that is centered at the origin. Okay, 2 marks there. 1 mark for stating it's an enlargement and 1 mark for having the correct value with the scale factor. Okay, so, and that will follow through from the first part. Part 2, we've got to say what A does. Now, A is the matrix -1 root 3 minus root 3 minus 1. At least I think it was. I'll just go back and look. Yeah, that was the matrix. Now we've got to do something here to find out what the combination is for this matrix. Now we know that A cubed is an enlargement to scale factor 8 and 2 cubed is 8. So this matrix here for A must then involve an enlargement of a scale factor of 2 in it. So if we take that 2 out as a factor, then that will leave us with a matrix that hopefully we can identify as either a rotation matrix or a reflection. Now in this particular case it's not likely to be a reflection, because when you square a reflection it undoes it and you just, you would just be left with something that wouldn't be appropriate. So this is likely to be a rotation matrix, and we can see that this matrix that we've now got left here, its determinant is -1/2 times -1/2, which is +1/4, and then it's minus -√3/2 times √3/2, which is 3/4, and that will become positive, so that's 1/4 plus 3/4, so the determinant of this matrix is 1, which is appropriate for a rotation matrix. So now all we've got to do is to identify the angle which has a cosine of -1/2 and a sine of +1/2. Sorry, positive √3/2. And so we know that on our cosine graph, for these two things to be true, that the angle must lie between 90 and 180, and the angle for which that is true is 120 degrees. Okay, and since that's positive, we know that's in an anti-clockwise direction. So this matrix A has two parts to it. It has an enlargement part, remembering we could rewrite this as an appropriate enlargement, okay, which has a scale factor of 2 or an area scale factor of 4 and a rotation part to it. So we can say that it's an enlargement scale factor 2 followed by, whoops, sorry about that, a rotation of 120 degrees, and I would put the plus there to emphasize that it's anti-clockwise, and again the center of that rotation would be at 0, 0. Now you need to show some clear working, that you've understood that there needs to be a rotation matrix and that you've got some way of calculating the angle. We could also have realised that the angle was 120 because a cubed takes you back to an identity, 8 times the identity, so that's equivalent to a rotation of 360 to get it back to where it started from, and so 360 divided by 3 also gives you 120. What you wouldn't know from that though is whether it's clockwise or anti-clockwise. So there's a method mark for 1 mark. You would get a mark for establishing the correct enlargement scale factor and 1 mark for establishing the correct rotation with its angle of rotation. Well, hopefully you found that solution helpful. For further help with your maths revision, please go to the Further Maths Support Programme website.